Hi friends, see today we will be discussing about second year physics, that is Doppler effect. This is also very important question in the IP examination. See, you can see here, first of all we will define what is meant by Doppler effect. Okay, see, this was first designed by the scientist named Doppler. So according to him, the Doppler effect can be defined as that when the source of sound and the observer both are in relative motion, then there is apparent change in the frequency of the source of sound. This apparent change in the frequency of the source of sound is called as Doppler effect. Okay, now you can see on the board I have drawn a small figure. You can see Vs is nothing but the velocity of source of sound, like an aeroplane, a train or a bus which is producing sound in the air. V is the velocity of sound in the air. V0 is the velocity of the observer. Okay, so first of all what I will do is, all of them are traveling in the same direction, that is Vs, V and V0. Vs is the velocity of source of sound like a train, bus or an aeroplane. V, velocity of sound in air, and V0 is the velocity of the observer. So all of them are traveling in the same direction. We'll see what happened. Okay, now let n be the frequency of the sound produced in the air. Now according to the definition of the frequency, what is the definition of frequency? The number of vibrations produced in 1 second, or number of oscillations produced in 1 second. So n is the frequency, means what happens? It produces n waves in 1 second from the definition. So one wave it will produce in 1 by n seconds from the definition of the frequency. Okay, so the difference between any two successive waves, the time lapse will be 1 by n seconds. You can see 1 by n seconds. Now what happens here is, let the source of sound like a train has started from a point S. Let it has travelled from S to S1. Let it has travelled from S to S1. So the displacement SS1 is given by velocity of the source of sound into the time taken, that means time lapse. Therefore SS1 is equal to Vs by n. So here SS1 I can write as Vs by n. Now for the observer here at the point O, what will be the apparent wavelength? Therefore this is apparent wavelength, lambda dash. Lambda dash is the apparent wavelength. Okay, now SO is already, you can find out by mathematical, that is V by n, because V is equal to n lambda. You know V is equal to n lambda. From that we can find out what is SO, because SO is nothing but the wavelength, that is displacement from S to O, which is nothing but V by n. Therefore what will be the apparent wavelength lambda dash? Apparent wavelength lambda dash is nothing but SO minus SS1. So that is equal to V by n minus Vs by n. So if you take LCM n, V minus Vs by n, let it be equation 1. So we got V minus Vs by n as the apparent wavelength, that is S1O. In other words, this is nothing but S1 for the observer. Now we know that V is the velocity of sound in air, and V0 is the velocity of the observer. Now what will be the relative velocity with respect to the observer? I mean relative velocity of the sound with respect to the observer, because both are in same direction. Therefore V minus V0 is the velocity of sound with respect to the observer. With respect to the observer, this is the velocity of sound with respect to the observer. But we know V is equal to n lambda. Therefore, V minus V0 velocity of sound is equal to n dash into lambda is nothing but lambda dash here, because the apparent wavelength already you have calculated, where n dash is the apparent change in the frequency due to the relative motion between the source of sound and the observer. So therefore already we got lambda dash here, that is V minus Vs by n. Therefore we will substitute here V minus V0 is equal to n dash into lambda dash here, that is nothing but V minus Vs by n. This is nothing but lambda dash, apparent wavelength for the observer. Therefore from this, if you cross multiply, we will get n dash is equal to n into V minus V0 by V minus Vs. So you can observe this one. We have obtained an expression for the apparent change in the frequency of the source of sound when source of sound, observer and velocity of sound all are in same direction. That is n dash is equal to n into V minus V0 by V minus Vs. Here n is the frequency of the sound in the air which is produced by the source of sound, like a train, bus or aeroplane. V0 velocity of the observer, and V velocity of sound in the air, and of course Vs is the velocity of the source of sound. Okay, so this is the general expression for apparent change in the frequency of the source of sound when all are then, when observer and source of sound in relative motion. One thing you have to put in mind, Doppler effect is only possible when there is relative motion. If both are at rest position, that means observer and source of sound, when both are at rest position, there will not be any apparent change in the frequency of sound. The sound will be same. Whatever sound produced by the source of sound will be same. There will be no apparent, that means increase or decrease will not be there. So to observe the Doppler effect, there should be the relative motion between the source of sound and observer. Either source of sound should move towards the observer at rest, or observer should move towards the source of sound which is at rest. Both are rest, then Doppler effect will not be there. That means there will not be any apparent change in the frequency. Okay.